Hello students, now let us talk about the characteristics of genetic code in 2 parts. This is part 1. Look, listen and learn. So let us see what are the characteristics of genetic code. Point number 1. The genetic code is triplet and commaless. What does that mean? So what I've shown you here is an mRNA strand, right? Okay, this is an mRNA strand. Now you know that the genetic code is a triplet. So there you go. The first triplet, one codon, followed by the next triplet, another codon, followed by the third triplet, another codon, then fourth triplet, and finally the fifth triplet. So what you are seeing here is you are reading the genetic code, right, in triplet fashion with no gap or no space, right? That means it is triplet and commaless. It is also non-overlapping. You don't see any bases being overlapped while you're reading the genetic code. Is that okay? Next property or next characteristic. The genetic code is non-ambiguous. What does that mean? Once again, I've put back the same mRNA. And just for reference, I'm going to put here a genetic code table. Okay? Now remember, AUG, which was your start codon, codes for an amino acid methionine. You can see and check from the table above me. Is it okay? So AUG codes for methionine. Then we move on to the next 3 bases, UCG, in a commaless, non-overlapping fashion. UCG, if you see in the table up there, codes for amino acid serine. So we're going to add serine next. The next one is GUG. Now GUG, if you look up there, codes for amino acid valine. So I'm going to add valine next. And the next one is GCC. Once again, if you check up on the genetic code table, GCC codes for alanine. So I'm going to add that up there. So what you see here is every codon codes for only a specific amino acid and no other, and that is why the genetic code is non-ambiguous. But there is an exception here. Let us see what is that exception. I've drawn another mRNA for you. Look at that first codon, right? You see there, GUG. You know that GUG will normally code for valine. You just saw in the above example. But sometimes when AUG is not available, then GUG can code for the start amino acid called as methionine and can act as a start codon. But if the same GUG comes anywhere else in the genetic code, it is going to normally read for valine. So this is an exception here. What I'm telling you here is when AUG is not available, GUG can act as a start codon and code for the same amino acid methionine. Is that okay? This is the only ambiguity. Otherwise, the genetic code is non-ambiguous. Moving on. The genetic code is degenerate. What does that mean? Look here. What do you see? An enlarged version of the genetic code table. Okay? I'm going to point out the 3 stop codons and move them aside. Is that okay? But the remaining codons, 61, are called as what? You guessed it right. They are called as sense codons. So we have 61 sense codons which have to code for only standard how many amino acids? You guessed it right. 20 amino acids. So many codons, but so little amino acid, which means you know that some codons is going to code for the same amino acid. Let us see one example here. You see down there, right? So what you see here, basically there are 4 codons, GGU, GGC, GGA, and GGG, and they all are coding for the same amino acid glycine. So in this way, because you have 61 sense codons but only 20 amino acids, you can say that 2 or more codons can code for the same amino acid, and that is why it is said that the genetic code is degenerate. Is that okay? Moving on. What is the polarity? How do you read the genetic code? What you see here once again is the mRNA strand. You know that the mRNA was synthesized from 5' to 3' direction, and is the same fashion that you will read the genetic code, which means the correct way of reading the genetic code is AUG from 5' to 3'. That is the right way of reading it. try to read it the other way, GUA, that is absolutely wrong. So whenever you are reading the genetic code, always read it from the 5' to the 3' position. Does that make sense? Okay. Now, next is start and stop signals. Some idea you already have, but I'm going to tell you a little more information here. What I've shown you here are 3 different mRNA strands. What is common here is the start signal in all 3 basically is AUG. You know that AUG is the start codon, which codes for which amino acid? You guessed it right, it is methionine. But now all 3 of them have different stop codons, and let us see which ones they are. The first strand up there has a UAG. You know that UAG is a stop codon. They give it a special name. UAG is also called as amber. In the second mRNA, what you see is UAA. This is also a stop codon. And UAA has a special name. It is called as ochre. And the last stop codon, which is UGA, right, has a special name, and that name is opal. So you have to remember that UAG is also called as amber, UAA is also called as ochre, and UGA is also called as opal. And all these 3 are stop codons or nonsense codons, and each one has their own specific name. Is that okay? Now this brings us to the end of the module where I talked about the first part of the characteristics of genetic code. In the next module, I'll be talking about the second part of the characteristics of genetic code. Till then, thank you and take care.